Precalculus Lesson 17 is all about properties of logarithms. We begin with the introduction of common and natural logarithms. This is section 4.2 in the college algebra textbook. Common logarithms are often used in chemistry and biology. A common logarithm is a logarithm with base 10. And because common logarithms are common, we frequently write the common logarithm with base 10 as simply log of x here. Log of 10,000, think of this as being log to the base 10 of 10,000. It would be the power that I raised 10 to get 10,000. So we can write log of 10,000 as being equal to 4. Log of the cube root of 10 raised to the power of 7. Think of this as log to the base 10 of 10 raised to the power of 7/3. And then we could simplify this logarithm as being equal to 7/3. Natural logarithms. These are logarithms with base e and are often used in mathematics as well as banking. The natural logarithm, having base e, we shorten to write it as natural log of x, ln of x. And this base e for this logarithm is approximately equal to 2.718. You're probably familiar with this number. Where this number comes from, if we take values for m and plug these values into 1 plus 1 over m raised to the power of m, say we start with 1 and we get bigger values of m, 100, 10,000, 1 million, we can see that 1 plus 1 over m raised to the power of m is approaching the true value of e. At this point, we have about 2.71828, and if we were able to continue with larger and larger values of m, eventually we would approach the actual value of e. Let's graph f of x equals e to the x. For y equals f of x equals e to the x, plugging in the x values of -1, 0, and 1, we would get y values of 1 over e, 1, and e, and these would give us the ordered pairs on our graph, the points on our graph of -1, 1 over e, 0, 1, and 1, e. When I graph these points, I think of 1 over e as being approximately equal to 1/3, and I think of e as being approximately equal to 2.7. Then we connect these 3 points on our graph with a nice smooth exponential curve here, and note that the domain is all real numbers, the range is all real numbers greater than 0. The asymptote here is y equals 0, and the graph includes the point 0, 1. Moving on to graphing g of x equals the natural log of x. Here we have y equals log to the base e of x, and we change forms to put this logarithmic form into exponential form of x equals e to the y. Then remember here x is a function of y, so we're going to start with the y coordinates of -1, 0, and 1. Find the corresponding x coordinates. E raised to the power of -1 is 1 over e. E raised to the power of 0 is 1, and e raised to the power of 1 is simply e. We'll plot these 3 points, 1 over e, -1, 1, 0, and e, 1, and then connect the 3 points with a smooth curve. We have a nice logarithmic curve here that has a domain of 0 to infinity, a range of all real numbers, the asymptote, x equals 0, and contains the point 1, 0. Let's look at f of x equals e to the x along with g of x equals natural log of x. Keep in mind this is log to the base e of x. And note that these two graphs are symmetric about the line y equals x, and indeed e to the x and natural log of x are inverse functions. The change of base property we'll look at next. Let a and b be positive numbers not equal to 1, and let x be a positive number. Then log to the base b of x equals log to the base a of x over log to the base a of b. As some examples, if we want to convert log to the base 7 of x minus 10 to base e, I could simply rewrite log to the base 7 of x minus 10 as log to the base e of the argument of x minus 10 over log to the base e of the base, which here is 7. And then we could simplify log to the base e, just write it as natural log of x minus 10 over natural log of 7. And note that sometimes I put parentheses around my argument for a logarithm, and sometimes I don't. Usually the rule for that is if I have only one term, so say I have the natural log of x, or I have the natural log of 7 in this case, I would not use parentheses. But if I have like the natural log of 2x or the natural log of x minus 10 or something, I would put parentheses around there. Now let's approximate log to the base 3 of 29. We can rewrite log to the base 3 of 29 as log to the base e of 29 over log to the base e of 3, which is the natural log of 29 over the natural log of 3. Then the reason I want to do this is your calculator has a button on there, LN. You can use that button on your calculator to plug this into your calculator. While it used to be the case that no calculators had log to the base 3, you might actually find that your calculator does allow you to put in other bases. But for those calculators that do not, we'll use the LN button, or you could do the same thing with log to the base 10 here. We find the approximate value is 3.065, and there we have it. Try on your own number 1. Approximate the following expression, log to the base 7 of 2/3.